Hello and welcome to part 4 of Description, Correlation and Causality. And in this section we move correlation onto looking at whether or not there are causal relationships between variables. And the two main parts of this are first to recognise that causality is not guaranteed by seeing correlation, and then some particular approaches for looking at how you might show causality and assess whether the evidence you have is evidence enough to show causality. So if we go back briefly to this scatter charts where we've seen this fairly strong positive correlation. When you start looking beyond the correlation at what might cause that, it could possibly be that when you have a lot of people per doctor, that means people tend to be unhealthy, therefore people can't complete their schooling well, teachers can't teach well, people need to spend resources on getting access to these doctors, therefore they haven't got resources to support children going to school and so on. So it could be that the number of people per doctor being high or low is influencing educational outcomes, or it could be that educational outcomes, lots of literate people means fewer doctors train, more literate people means lots of doctors train, could be this is influencing this, or it could be that there's no connection at all between those things directly. It could just be that the general level of economic development of the country influences both of them. So down here you have countries that are very wealthy because they're highly innovative and very good trading, or because they have a colonial past which means they've become rich because they've exploited other countries, or whatever reason it is. You've got wealthy countries down here with low illiteracy and very few people per doctor, and these are the countries here who have been maybe not so productive, or fewer natural resources, or poorer governance, or have been exploited by the other countries. They're ones who've got high literacy and also lots of people per doctor. But the problem is that all these causal relationships and others are possible, but all you see is these red dots. So how do you know which is which? So let's take another example that's a bit simpler, just looking at maize yield and the fertilizer use. So more fertilizer use, more maize yield, you'd expect a positive correlation. But what's driving this? Unfortunately, there's lots of possibilities at work here. Could be that causing that. Could be the x-axis causing the y-axis causing the x-axis. This is the nasty one. Could be something completely different, Z, some other factor you haven't even thought of, like general economic development, causing both of them with no connection between them at all directly. Or another nightmare is when both these first things are true. So this affects this, and this then affects this. I think it's really hard to sort out what's going on. So these are the possibilities for the fertilizer and yield example. So Z is the one here. If you're just richer, then you both use more fertilizer and you get higher yields. And it's you being rich, or having good family connections, or living in a place near a big town, for example, that affects those things. They're not actually affected directly themselves. Or it could be that time's the thing that changes it. It could be just over time, people are getting more educated, getting more switched on to using fertilizer, or corrupted by the agro industry, or however you want to put it, and are using more fertilizer, and also yields are getting bigger over time. So, and you have this one where they influence each other, and you can think of more complicated combinations. Unfortunately, as I say, you don't see any of this. All you see is the scatter graph, and you have to figure out what on earth is going on, if anything. So it's tough. And here's going back to a more complex example, an example based on real research. This is a series of papers that are done by the University of Nairobi, the researchers down there, who were looking at, okay, it seems there's some sort of pattern where households that have more migrants, more members of their household who have migrated away to either to Nairobi or overseas, they seem to have different income levels to ones that don't have those household members. So, and it could be because of remittances. So the question they were asking is just having migrant household members living elsewhere, perhaps in Europe or Nairobi elsewhere, is there some sort of influence there, sending remittances, money home? Is that having an impact on money being sent home? So if you assume that, that's the only possible causal pathway. So all that can happen really is if there's migration, then they can be sending money home, that can be having an influence on income. If that's the only causal pathway, then if you see that when you plot amount of migration here, or number of migrants, and here amount of household income, if you see that, and that's the only causal explanation, then it's easy to interpret. This says, okay, well, having more migrants does increase household income. That's causal relationship shown. So migration raises household income. Done. Similarly, if that's the only possible causal pathway, if you see that, that means, hey, this doesn't really have an effect. Migration doesn't affect household income. And if you see this on your graph, that means, hey, look, migration does affect household income, but it affects it negatively. Must be that these people are having to kind of pay money to get people sent abroad or pay money to support when they're there. So it's a drain on household income. But the nice thing is that whichever one of these you see in your data, if those are the only causal possibilities, then you just read it off, you know what's going to happen. So it's a nice, simple end of story. Problem is, of course, this is not the only possible causal relationship. You could have, for example, this. It could be it's possible for migration to influence household income. It could be it's possible for household income to affect migration, because wealthier households maybe are more able to afford the contacts and the fees and have the contacts overseas to get people to become migrants. Or it could be that more desperately poor households are more likely and more willing to send migrants. So it could be causality in both ways. And this, even though you've only added in one possible blue arrow of causation, this makes the whole job for interpreting your data a bit more of a nightmare. So this first possibility is known as reverse causality. And this time, when you see that, well, what could it mean? That could mean that migration, okay, it does raise household income. Or it could mean that, okay, there's no real effect from migration to household income this way, but it could mean that rich households migrate more. So the reason you're seeing this positive correlation is because wealth here influences migration. Or it could even mean that migration lowers household income. So there's a negative effect this way, but this effect is bigger, so it's overpowering it, so you don't see that in the data. Or it could mean that this does increase it, but this increases it more. There are just countless possibilities of interpreting just that one positive correlation because you've got reverse causality. And then when you start saying, okay, well, how do you interpret it if it was like this or like this, if there's reverse causality, then that's consistent with many possible different causal relationships. Okay, so that's the bad news, that any scatter graph can then mean just about anything. However, I don't want to leave you with bad news. So what I'll do now is I'll leave you with even worse news, which is, as well as that, there could be a whole zillion other factors like the failure of crops, the demographic structure of the households, the attitude to risk of people, the infrastructure, the local economy, the local political economy, other effects, the effect of other economies migrants are going to, other stuff you can think of, civil unrest, cultural changes, all kinds of events could and factors could affect what's going on here. And if they're not modelled, if you don't include them in the scatter graph, that can cause what's called omitted variable bias. And that's something to bear in mind that, for example, if just one of these, like infrastructure is important, if it happens that in the area where a lot of migrants come from, maybe they've done a lot of extra road building or infrastructure has been put in, so that infrastructure, electricity supplies and water supplies, maybe that increases their household income, and it happens to get targeted on the same areas that the migrants came from, then what you're going to see is all these migrant families are going to get wealthier. Your scatter graph will be positive, and you'll say, oh, I've got some evidence that migration is increasing household income. Must make it easier for people to migrate or people to send remittances. This is great. But in actual fact, it was the thing that did the job was building the roads, putting electricity in, the better infrastructure, because that effect has been soaked up because you're not measuring that. It's been soaked up by the migration variable. So that's really tough. And when it comes to drawing, well, what are the possible patterns? Then it's like, all this stuff could happen. And then when you see one of these happening, it just tells you really nothing. Or it says, okay, there's something maybe going on. If you see this, I mean, but even here, there could be a lot of causality going on, but it's all masking and swamping each other. So you can't figure it out. So the even worse news is that you get, as well as joint causality, you can have multiple unknown or known or unknown variables. So it's really tough to map it out. So approaches then. What have people done to try and sort this out as well? I'll go through a couple of those. There's lagged variables, and there's instrumental variables, and there's some others like control variables and experiments. So let's just look at a couple of those. So the idea of lagged variables first then. This is the idea that lagged means the value of a variable from a previous time period. So if I've got poverty today, that's my variable, but if I've got poverty 3 years ago, it's a lagged variable. The idea is if the lagged variables of this of x, so the lagged variables of the lagged values of fertilizer input are correlated with the present values of crop yield, but not the other way around, that suggests that X must be causing Y. So if previous year's yield is not correlated with today's fertilizer use, but previous year's fertilizer use is correlated with today's output of yield, that suggests that causality is going this way. So it wouldn't be per previous years, it would be previous months. Yeah, that would suggest that X causes Y. If that's the case, then the phrase we use is that X is Granger causing Y. So that Granger cause means in one direction the lagged variable has an effect, in the other direction it doesn't. We'll look at instrumental variables in a moment, but first of all, let's just look at more detail at the lagged variable. So here's a simple example of lagged variables with the migration example. So let's say this was the number of migrants that you observe from a household living overseas in a particular year or in the capital, and this is the income in that year per person. Correlation coefficient, if you plot it, okay, so if you put those on a diagram, calculate it, 0.585, which that's a reasonably strong correlation between the variables in the same years. But what's causing what? Let's try the lagged variable approach, which is this. So here I've changed the correlation coefficient in the graph. I've looked at the previous year's household income and correlated that with how many migrants they've got this year. Yeah, so I'm looking at that correlation. So you lose those two bits of data, but that's a minor problem usually. If I do that, the correlation pretty much disappears. It's pretty just flat. So it's minus 0.079. It's actually nothing. So there seems to be no correlation at all, really, between previous income and current migration. But if I switch it the other way, look at the correlation this way, previous migration and current income, then you get a clear upwards and a much more solid-looking line with a very strong correlation coefficient. So that makes it even stronger than the first correlation. So there's a strong positive correlation between current income migration in the previous year, but nothing at all looking at the lags the other way around. So in that case, we'd say that migration is Granger causing income. So that gives us some evidence that there is a causality and it's in this direction rather than the other direction. So that's lagged variables. However, what the lagged variable has done is it's coped very nicely with the reverse causality problem, but what it doesn't do is cope with the problem of possible other variables. So that's why you try and use things like instrumental variables to try and win out those effects and identify only one possible causal pathway. So in the Nairobi study, they considered a few instrumental variables like household history of migration, household network outside the local area. Sorry, I forgot I had to rewind to this one. So the idea of instrumental variable there is you think of another variable, W, that's correlated with the X variable, but you know it can't be caused by X. And you must use logical, real-world reasoning to say, okay, these things can be correlated, but X can't cause W. Then, logically, if W is correlated with Y, you can rule out Y causing X. Because even if there's some backwards causation that Y is actually going to, if Y really is even causing X, then X can't have an effect on W, so you wouldn't see that. I'll show you a bit how that works out in the actual example in a moment. So these are the instrumental variables they considered and demand for labour. So each of these things can influence migration, if you think about it, but they can't be influenced by migration. Even the household network is something you've built up over many years, so that doesn't change if one more migrant comes this year. It doesn't change very much. And certainly demand for labour isn't changed very much, or history of migration isn't changed very much by a couple more arriving this year. So history is something in the past that can't be changed logically by something happening now. So if there's a correlation of any of these four things, or all of these four things, with household income, that implies that the causation must be going from migration to income. It's slightly easier to see it on a diagram like this. We're saying that this household history of migration, that could cause migration, but migration can't cause that. So there's a blockage going this way. So when you're looking at this diagram here, if you find these two things are positively correlated, you can't argue to say, well, okay, sorry, if you find that this and this, the migration and household income, are positively correlated, then you know that the causation isn't going from here, because even if that can push that up, that can't have any effect on this. So the causality can only go this way. So whatever other factors there may be, the causality can only go this way because there can't be any, sorry, can only go this way because there can't be any pushback the other way. Yeah, so that's putting it in words. And indeed, that's what they found, a positive effect of migration on causation. So if you see that, it means that migration raises household income. If you see the opposite, it means it decreases it, but that's what they saw. And then finally, two other approaches to showing causality you'll get more about in the rest of the module. There's control variables, which is a huge area. What you're trying to do there is to cover all these other confounding variables. For example, you're trying to think of all this stuff here, as many as you can get. And instead of just getting data on migration and household income and putting it on a scatter graph, you get data on as many other things as you can and put that into a more complex model, such as a regression model, which you'll do with Paul later in the module. So that's one other approach then. And essentially they're quasi-experimental design. So you're trying to simulate an experimental situation. And you'll do that more in the econometric weeks. And then the experiments, where you try and eliminate the effect of all these confounding variables Z by using randomization. And we're going to do that in the next lecture. Okay, so to conclude, description can, as you saw in the first part, can summarize large amounts of complicated data. It can provide you a basis for coming up with theory and generalization. And it can help you work with these useful ideas like distribution and the level and the spread. So the shape of a distribution, the overall level, how spread out it is, narrow or wide, those are important ideas and they get applied later in tests. Then in correlation, scatter graphs are a good way in. Correlation coefficients can then give you more precision about strength and direction, and you've seen how to calculate those. Finally, causation is not implied by correlation. Causation is not implied by correlation. Further analysis is vital, and we've seen a couple of ways you can start to do that. Okay, there's the references, including these interesting references on that Nairobi study of the migration. So please, questions in the live session or questions on the forum or Blackboard or elsewhere, but for now, thanks for watching.